Our second speaker is Dr. Mohammad Zee Ahmed. So we go with Z. That's what we call him. So he is an assistant professor of turf and ornamental entomology at Clemson University. So he has over 12 years of research and extension experience in ornamental pest management. Prior to joining Clemson, Dr. Ahmed worked as a research entomologist with the USDA Agriculture Research Service in Florida and contributed as a scientist with Florida Department of Agriculture and Consumer Services. He also completed a postdoctoral appointment at the University of Florida. Dr. Ahmed earned his PhD from the University of Pretoria in South Africa and his master's degree from South China Agricultural University, with research largely focused on diagnostics and biology control of ornamental pests such as mealybugs, scale insects, and whiteflies. So Z, floor is yours. Okay.
Thank you. I appreciate your kind introduction. Can you see my slide now?
Yes, we might clear.
Okay. Good afternoon, everyone. As Dr. Shimet introduced me, I'm Zee Ahmed. I work as a turf and ornamental entomologist at PDRAC, which is Research and Education Center of Clemson University, located in Florence, South Carolina. So before I dive into my talk, I wanted to help you to see the market size of turf and ornamental industries. I used example here for South Carolina, but you can see how much it is impactful in general by this example. I could not find exact number, so I used already a published number from 1999 and counted for inflation rate, and it seems like turf and ornamental industry market size just alone in South Carolina is about 2.6 billion. And it's considered among top 10 states for turf for the job market. And it's considered among top states in salt production. The idea for this slide is to help you to see how tremendous impact of our turf and ornamental industry has on job market and in general on economy. And this is just an example from South Carolina. If we take a number from southeastern states, including Georgia, it will be huge impact. Okay, so now moving to what challenges we have in turf and ornamental industry. Main challenge we all know is pest species, and among pest species we have particularly invasive species which we are dealing with. How we define pest species? I really want to start my talk with this because it's easy to use those terminology, but there are folks who may wanna just have a refresher. So any of various organisms that harm crop, livestock, otherwise interfere with the well-being of human beings is considered pest. So we know there are a lot of pest species, including pathogen and insect. As an entomologist, I focus on insects, and among insects, the reason I feel like I'm lucky to work on insect because 80% of living species on the earth, they are technically insects. And I wanted to get the exact number, but obviously there is no way to get exact number, but approximate count is that we have about 1 million insect species on the earth. And there's no study so far done how many are exactly pest. Based on different databases, it seems like only 1 to 3% insect species are pest. So not all insects are pest. And among those 1 to 3% pest, there are a very handful of them which basically cause or consistently cause any problem for our turf and ornamental industry. So not all of them. But those which are causing problem, they are causing sometime problem consistently every year. So what makes them more pestiferous is their ability to be resilient. Here I want to give you example of this Antarctic midge, which is only native insect which is found on Antarctica. And this insect species living in Antarctica, where it is humanly impossible for almost all species to live, but they are surviving and they are reproducing. So what they are doing there is actually I want to use to show you a resilience what insects have, and that's the main problem we that's our job security too, because insects are very resilient. This species developed its life cycle biology in a way that its life cycle is for 2 years, which is which is not usual for insects, and it can go to diapause on different life stages as immature, and it try to align its adult emergence period with the summer, so it's less cold for them, relatively very cold for us, but they want to nicely align their life period, and they did that, or they adopted, or they evolved to do that now in 2 years. And then they have these enzymes which they release in their body, which help them to avoid or to prevent them from ice damage. So an example here is to show you that how resilient insects can be. So now I'm switching gear towards the management steps, which I feel like obviously is very abrupt change, but I really want to focus on this slide before I move on. So in general, there are different steps in management, and each steps, they are nicely coincide with each other. You cannot skip those steps. So first step in general, I put them together on this slide, 8 simple steps. We need to know, first step is we need to know where the insects are, right? Indoor, outdoor, in the landscape, in nursery. We need to know the site, right? Once we know the site, we want to know which season we are having the problem, and then which host plants they're more prevalent, right? And then what is the source of those host plants. After these 3 steps, we reach at the step which is the fourth, and it is in the middle, almost in the middle. So this step is diagnosis. We want to know what species we are dealing with, and if this species is a pest or not. You saw that, or how big this pest is. If it is an invasive species, it's already established. Native species already established. Invasive species are knowing about the species name and the history of species. That's the middle step. You cannot skip any of these steps, especially the fourth step. You have to go through the fourth step to reach at fifth. And the fifth step, once you know the species, you want to learn about its biology. What is its economical threshold level? What is its life cycle? What the life stages look like? And then how many generations it has per year. So that will help you to reach at step 6, which is a decision making. You know the biology now, and if it is an invasive species is recently arrived, our immediate action in general is obviously for most of invasive species, when we dealing with them, we don't have a management plan ready. So chemical control is something which we have to apply. And then which method we're going to use, what time we're going to apply, how we're going to make sure which type of insecticide we need. After that, the step 7th, which I feel like get overlooked in several cases, because once we spray or once we apply our management, we really don't follow up. And then follow up, 7th step is really crucial. So, and that takes you back at step 5th. If you see on a screen, I don't know if you can see my mouse. So 7 goes to 5th if if your control doesn't work, and that is the case in some time with invasive species, because we really don't have any management plan ready. We're using the chemical control based on the studies which were done on related insect species. So we use those to see if we can control it. And if we do follow up, we can we can confirm. And if we have to change the management plan, then go back to 5th step and then do 6th again, and then reach at 7. After 7, the step 8 is very crucial. And that is also, in my observation, has been overlooked in several cases, because people don't try to keep the record, and they don't really provide feed. So if you're dealing with some stakeholders or your landscaper, you got to get the feedbacks, make sure that if you think the control worked and your customers are also as satisfied as you are with that control strategy. So these 8 steps I want you to keep in mind for my talk in further slides. Okay, so here's an example. During my postdoc, I worked on a Ficus Whitefly. These are 2 residential houses on Palm Beach in Florida. We received this phone call from one house, which is on your left, saying that we could not control Ficus Whitefly. Even the landscaper was giving up, but the house next to that house on your right has really good control. So we started observing what is happening, and we started going through the insecticide application records. It seems like the hedge on Ficus hedge, which is very common in South Florida, almost every house you find on Palm Beach has this hedge. So the hedge on your left, which was looking bad, seemed like had overlapping generation. At least population was there for at least 2 to 3 generations. And we noticed that the person who applied the chemical control on the left has not scouted the plants, and it didn't do the follow-up. There were life stages, and coverage was not good enough. There were several issues, and then the scouting they found immature whiteflies which were alive, and they were not clear about if they were alive or dead, and they didn't do a follow-up application. So that goes back to, again, those 8 steps which I mentioned, that better diagnosis, better scouting can help you, which is the step in the middle step. So that's just one example from real life. Okay, so we have, as I mentioned earlier, we have a chemical control option, which avoiding that sometimes is inevitable, especially with invasive species, because we don't really have any management plan ready for invasive species, especially in Southeast, because we are considered gateway to US. Species are coming through Southeast to going towards North, and there are cases when species come from northern states too, but most of them we have invasive species entering in from Southeast, including Georgia, South Carolina, and starts from, in most cases, from Florida. So chemical control is our first approach, and then we take our time to understand what integrated pest management strategies we can use to avoid unnecessary use of chemical control. Here I want to bring the sustainable pest management term here. There are different school of thoughts about this term. And there are people who may think this is the same thing as integrated pest management. I put it here separate. I wanna obviously tell you what my philosophy about sustainable pest management is. Again, it can vary with the situation and with the different school of thoughts. I believe sustainable pest management is when you have a long-term and economical control. So some may argue you can get that from integrated pest management too. Yes, if you can, that would be sustainable. So sustainable pest management is something which I believe we should be targeting. It can be sometimes challenging with invasive species, because we have to learn about invasive species when it is newly showed up is newly arrived here. So, but for long term, we have to target for sustainable pest management. Now I'm switching gear. I wanna have you some understanding about insect, which I believe most of you already have, but it would be good to have a refresher. So insect, what is insect? There is, if it has 3 pairs of leg, 3 body parts, head, thorax, and abdomen, right? And typically 2 pair of wings. Some groups like houseflies, dipteran, they have 1 pair, and last pair is there, but it's not functional. They have 1 pair of antenna and usually 1 pair of compound eyes. And then there are simple eyes, which is present in many groups. So that's very simple structure of insect. And there you will find, I want to help you to see the diversity of insects. You will find them in different shapes, different colors, and importantly, you will find them in a different habitat, and they learn to camouflage with habitat in terms of size, in terms of their colors, in terms of their feeding habits. Very diverse group. So now I'm switching gear towards the most important things which we need to know about insects is that they have two different type of mouthparts, chewing and non-chewing. And then within non-chewing group, we have piercing sucking. We have a piercing sucking are mostly whiteflies and most of Hemiptera. And then we have siphoning, which are Lepidopteran. And then we have sponging mouthparts. So it is important to know mouthparts because that will help you. And further, I will explain in my talk when you're applying insecticide. Okay, so after learning insects are diverse group, they have different mouthparts. Another important thing is that they have different life cycles. So one life cycle is complete life cycle, in which you will find on your left, you can see eggs, larvae, pupae, and adult. And pupae are inactive. Eggs are inactive too. And larvae is the most active stage here, and they usually cause damage. In contrary to this life cycle, there is an incomplete life cycle where eggs are laid, and then there are immature, which are look-alike when they become older. They are young nymph, then they are older nymph, and then they turn into adult. And in this case, in incomplete life cycle, all these stages they are feeding. In case of complete life cycle, larva is feeding. And the butterfly has even the feeding site different than larva. Or if butterfly is mobile, can go to another location and not really causing damage, but larva is the causing damage. But in incomplete life cycle, all life stages you can see cause damage, and they usually find at the same location. So yeah, it's important to know if it is an incomplete or complete life cycle. So okay, now go back to diversity of insects. In US, this slide which I have here, it's based on the number which I could find. And this is something which I feel like is the most updated based on my research. There are 28 orders of insect in US and Canada. There are 600 families, and those 600 families has over 12,000 genera, and about 86,000 species of insects are in the US. As I mentioned earlier, not all of them are pest. There's 1 to 3% are pest, and among 1 to 3%, very handful of them are problematic in turf and ornamental industry. So here I classified them, which I feel like you usually find in a turf and ornamental landscape. There are coleoptera, which are beetle, dermaptera, which are earwigs, diptera, flies, hemiptera, which is one of the most common pestiferous insects we find in turf and ornamental. And then we have Hymenoptera, which are ants, Lepidoptera, butterfly moths, and Neuroptera, which is lacewing, which is not really pest, Arthroptera, grasshoppers, and Thysanoptera. So these 9 orders, which are based on my based on the number of frequency I find in literature, are very common in the turf and ornamental industry. Okay, now I'm switching gear to the next step. If you remember in the management steps, that's once we know the diagnosis, we know this is insect, which insect it is, what mouthpart it has, and which life cycle it has, if it's complete life cycle or incomplete life cycle. The next step is to knowing about their threshold, right? Economical threshold is something which we use in entomology to decide whether we have to apply control now or not. Economical threshold, if you miss economical threshold, then insect reach at economical injury level. In simple term, economical injury level is when you apply, and then the cost of applying control becomes equal to the cost which is representing the damage which has already happened. So you want to take action before economic threshold, or right at the economic threshold before economic injury level happen. This is something which we use in entomology, and that's something which is very common across different disciplines. But in turf and ornamental entomology, we have 2 more thresholds. One of them is aesthetic threshold. So whether it's causing economic damage, it becomes it is not important when we are dealing with aesthetic threshold. In aesthetic threshold, if there is a pest on your roses, or if there's a pest on ficus hedge, and this is causing the leaf drop, or is causing it basically making your plant appearance look bad, you got to control, right? So in so that's not really associated with the economic threshold, but it's more visual, and that can vary from customer to customer, and that can vary from stakeholder to stakeholder. If you're a homeowner, your maybe aesthetic threshold is very low. If you're at nursery, that your aesthetic threshold may be very lower than even homeowners. And then if you're in the landscape, if you are in a public garden, maybe aesthetic threshold vary there. And then there's another threshold, which is emotional threshold. And that's something which I feel like it's very, very important. And that is something which we've been using in turf and ornamental industry. For example, in the golf course, we cannot really afford any single pest. If there are people who are playing golf, they don't want to see any pest, right? So their single specimen or single caterpillar can be a threshold. And also in case of house, in your house, if you have one house fly which is really not causing any economic damage or may not really transfer any disease, most likely, but it is a threshold because you got to control it, right? So I want to help you to see these three thresholds when we are planning any management. Okay, so the next step is once you know the threshold, there are different types of control. One control is short-term control, which in most cases we deal with short-term control when we are facing invasive species, because chemical control is something which we have to apply. So if you see, I put together here two colors of line. One is red, other is orange. Red in this graph, I am trying to show the species which just arrived. This is just assumption, and the orange is the one which is invasive but is already there, and we might know the management strategy for that species, because it takes some time to learn about invasive species, and then once we are in the middle of learning about one invasive species, another invasive insect pest shows up. So we're dealing with invasive species, newly arrived invasive species, and already established invasive species together. So aligning the management in the way that species which you are dealing, which is new, and the species which is already there, you can apply control for both. So for short-term, chemical control works, and for most of the time for invasive species which even we don't have any information, we apply chemical control based on the related groups which we've been using to plan chemical control in the past. Okay, then there's a medium-term control. In the medium-term control, but that usually not work when we're dealing with the newly arrived invasive species. In medium-term control, I believe we have to bring other control strategies like culture control, mechanical control, and some other ways to control in addition to chemical control to avoid unnecessary chemical usage. And that can be very challenging when we're dealing with newly arrived invasive species, because we really don't know about anything about its biology, how many eggs it lays, and what is its potential to complete the life cycle, on which parts of the plant it will feed most, and where it's going to pupate. It takes time for us to learn about that. But for species which are already established, integrated pest management, I believe, helps for medium-term control. Now I wanna help you again to re-emphasize on long-term control, which is a sustainable pest management, where you are, and obviously to arrive where the sustainable pest management strategies are ready, it takes time for invasive species, because we have to learn about their biology, learn about their ecology, we have to learn which non-chemical controls are working, what cultural control has potential to decrease the pest, and it takes some time. But we usually, as entomologists, reach at that stage, and we're trying to gauge ourselves to reach that stage faster. But again, unfortunately, invasive species comes, or they shows up faster than before we are even have a plan ready. But we in most cases we achieve this with the passage of time. Okay, so in short-term control, again, even in medium-term control, chemical control is the most important when we're dealing with invasive species. So I want to really give you a quick highlight about chemicals which we use. So we use two different types of pesticide. One is natural, other is synthetic. Natural, we can include microbial insecticide like BT, and it can also include plant extract, neem oil. And then there are other options in natural control. But synthetic is something which we've been using, and there are different groups in synthetic: carbamate, organochlorine, pyrethroids, and organophosphate, which are among common synthetic insecticide. Then there are other groups like insect growth hormones, neonicotinoids, and dynamite. So I want you to have some understanding about natural and synthetic controls on this slide. And of those insecticides which we are using, they have different groups. So why it is important for us to know their groups? Because each insecticide group has a different mode of action. Some insecticide only work when insect is feeding, and some insecticide only work if insect is coming in contact with that insecticide. So yes, knowing the type of insecticide and then knowing the mode of action which it has will help. Just to quickly summarize last few slides, last slides which have been going through to reach at this stage. So we learn about there are the diverse insect types. We learn there are different mouth parts. We learn there are different life cycles. Then we learn there are different type of insecticides, and then we also want to know which mode of action each insecticide has, because we have to combine this all knowledge to decide the management strategies against any insect. Okay, so now I am switching gear to one of my extension topic which I've been for last few months I've been dealing here in South Carolina is a spotted lanternfly. I'm sure in Georgia we also have similar issue. It's spotted lanternfly showed up in South Carolina about a few months ago, and we've been receiving phone calls. We have seen people are so much concerned. I want to use spotted lanternfly here as an example to show all those stages, all those steps which I mentioned in my talk before, to just refresh you again by using a real pest example. Okay, so first we want to know what is spotted lanternfly, right? So if you see in this video, I'm going to touch this and it hop, right? So it's a hopper, because most people really, it's just a leaf, just like a leaf hopper. So leaf hopper is in group Hemiptera. Hemiptera are true bugs. So it is very important to learn what is actually the pest or invasive species we have is here, which group it is. Okay, so then next step is to learn about its biology. As I mentioned earlier, there are two different types of mouthpart, chewing and non-chewing. This one is hemipteran, and in hemipteran there is a non-chewing mouthpart which is pyrethroid sucking. So it has a pyrethroid sucking mouthpart, and in life cycle, it has incomplete life cycle. It lays eggs, and then there are immatures comes out from egg. First instar, second instar, third instar, fourth instar, and then they turn into adult. So remember, I did touch a little bit about why it is important to know the life cycle, if it's incomplete or complete, because we know if it is incomplete, most of immatures and adults they will be feeding. So it's a longer duration of feeding when it comes to incomplete life cycle, because all immatures and adults they are feeding there, and they most probably are in the same habitat, in the same plant, so or in the same niche. So now after that, the next step would be, once we know it's an incomplete life cycle, how many generation it has. That will help us to learn about how we're going to plan this management, because we know controlling immature is always easier, especially those immature which are immobile. They're not going to move, because in this incomplete life cycle, immatures, they don't have wings. Only adults, they have wings. So we know, based on knowledge from northern states, it has one generation per year, and we are hoping information from northern state will be applicable in some of our southern states too, but they may vary. So we are still at the stage we are learning about its biology and ecology according to southern states. But I'm using information from northern state just for us to have some understanding for this pest at this stage. Okay, so now we know it's incomplete life cycle, and it has one generation per year. So now we want to know these life stages, how they align with the different calendar months. So we know it technically from January till June there will be eggs, and eggs can overwinter. So, and these eggs start hatching around April, May, June time. So that's where the first stars will be visible. And then around June 2nd, it will the first star will turn second star and third star, and July and August they will turn to fourth, and the fourth star turn into adult, and that starts from July and it lasts in December. And when, since the adults are there, they will lay egg between September and until June next year. Disclaimer, this calendar is based on our knowledge from northern state, and we are still at this stage learning about this pest, how its biology is gonna turn out in southern states. But at least what we have, based on that, we know, for example, we are in September. So if you are dealing with spotted lanternfly in your area, you will be finding adult at this stage, maybe some fourth star, and then eggs are already being laid. So this is the time, and you have to keep an eye on egg laying places where they are laying eggs, because if you remove eggs now, you can reduce its spread, and you can also avoid high population which will be there if eggs are there in spring next year. It is very important to learn about what pest it is, then learning about its biology, how many generation it has, and then how we can align its biology according to the year calendar. Very quick about diagnosis. You can see how many eggs this can lay. And these eggs can easily be mistaken as maybe the pieces of, or maybe just a mud on a tree. But in most cases, when there are a high number of eggs, you will find high number of adults around there. Here's a high number of adults on one tree. I want to just show that how dense population can become if we don't apply control at early stage. So this is a location where we visited in Tennessee, and I want to show this to help you to see how much aesthetic damage it can cause. This tree whole trunk was covered with the mold. That mold was a result of honeydew, which these adults they secrete, and then honeydew catches mold, and that turns black. And then even the stones around that tree and the other branches around that tree, they were also looking blackish during our visit. And this was, if I'm not mistaken, was a ground zero in that area. And that, if you see in the back, there's a train, and we suspected, and that might be true based on other examples, that there were these adults were moved there, or they were moved there through the train transportation, that's most probably the cause, or they came as an egg stage, and then they just established in that area. But the picture here, just to help you to see how much aesthetic damage can be done by spotted lanternfly. Here you can see the sooty mold on all leaves. There was in that place, I remember It was just dark. It was so bad. Honeydew and mold was everywhere. These branches were covered with honeydew and mold. So here I want to just quickly give you understanding about when species comes in other location, how it goes to different stages. So since we deal with invasive species very often, very frequently in southern states, when species arrives, it goes through the lag phase. That's the period when species is not really become problem, but it is there, and there are people who are dealing with it, but they are not seeing it high population, or we know it is there, it is getting a higher population, but we don't really have a control. Then it goes through exponential growth phase. This is the period when we apply control, we can avoid this peak, which is called invasion peak. And that's where I believe is where if we apply those 8 steps, we can avoid and we can manage this exponential growth phase, because we diagnose it and we start applying proactive control. But if we miss this phase, then it will reach the invasion peak. Yes, one would argue that once invasion peak, you reach invasion peak, there is a time when species go back to equilibrium. Yes, but the damage, economical damage, aesthetic damage, and in general annoyance it causes during invasion peak, that sometimes costs so much money. So it is important to try to apply control during exponential growth phase, avoid the invasion peak. If we reach an invasion peak, unfortunately, because we didn't have the right tools, but then we try to avoid to make sure the invasion peak will not last longer, so we can reduce the damage, especially economical damage. So it does go, the species, based on my experience, I worked on at least 3 invasive species during my time in Florida in last 12 years. And based on my experience, invasive species, they go back to equilibrium, but it's just a matter of time how long it takes before they go back to equilibrium. Because once species establishing their high dense population, other natural enemies, which are not really natural enemies for those new invasive species, but they are natural enemies for other species, they start shifting their feeding habit towards those invasive species. Or then there are some other weather and climatic condition, other shift in a plant usage, and also management that helps to bring the species back to equilibrium. But how long it's going to last at invasion peak, that depends on us, how proactively we try to control it. Okay, so what is the geographical distribution? This invasive species is native to South and Southeast Asia, and apparently before coming to US, it started invading other Southeastern or Eastern, I would say Eastern, other East Asian countries before it came to US. And when it came to US, that was around early, forgot exact year, they should be here. I think in last 2014, if I remember correctly. So when it arrived here in last 10 years, it has been spreading to now it is in 19 states, including Georgia and South Carolina. Georgia, it was recorded into last year, and South Carolina we just recorded a few months ago. Idea is to show that it is invasive and it's spreading in Southeast. It's going to be just a matter of time and it will be a problem in Southeast. So we receive phone calls about very cryptic looking like eggs, which homeowners believe they are eggs of spotted lanternfly. So it is very important to know their eggs can look like lichen, or look like fungi, or can be look like some just tree sap. So here's the true eggs. So if you see on my mouse, when these eggs are freshly laid, they are waxy. They have waxy appearance. They are very glossy, waxy appearance. With the passage of time, they accumulate mud-like appearance on them, which looks like a mud, and then With the passage of time, that mud get removed, and if you remove that mud manually, you will see seed-like eggs inside. And if there is a hole and there's a slit inside, that means adult, excuse me, not adult, immature has already been hatched. And then the older eggs look like here. You can see, I'm going to show you more picture. They sometimes camouflage with the bark. Here I want to show you, there's a three appearance of the eggs which I notice in the field. White, and then it's going to be look like mud, which if mud, once mud is removed, seed-like, and then they become just like a bark. Here, I don't know if you can see, this trunk has egg laying which were there for a while. Here's a close-up, you can see, but from the far it was almost impossible to see there were some sign of eggs. Here is more close-up of some branches which had eggs. Okay, so I already mentioned about the life cycle. Just want to show you here the size. So it's not really big, but it is relatively big from some other invasive species. Maximum it reaches around 1 inch, maybe say 25 millimeter. So obviously first instars are really small, then second star they become bigger, third become bigger. They first to third they are black and they have white dot on them, and the fourth is reddish. And then adult, I'm going to show you later. If you see the adult, you may see that it is easy to identify them, but there are people who actually sent us the pictures of some bizarre moth. I'm going to show you next slide, and they thought this is spotted lanternfly. So how I identify is that they have a base of the wings, they have black spots, and the tips they have a net-like appearance. So here there are some look like adult. It can look like sometime tiger moth, or could be look like milkweed bugs. Okay, so once we know it is there, trapping is one method which people use. There are different types of trapping methods are available. One method which we have seen relatively effective, and there are different methods, and you will find more information about them. Here I am showing this shade lamp trap because this is something which I observe by myself. So but I know there are some claims about some traps which are more effective than this one. So I have seen, if you put this there, adult, they usually go underneath this. So you will find this, I have seen with my observation, this is effective. Okay, it has a really broad host range, which is case in most of the time with invasive species, over 100 plant species from 33 families. In nursery plants, it can goes to roses, tulips, or in orchards, apricot, apples, cherries, figs, peaches, plums, walnuts. In ornamental trees, tree of heaven is its favorite host, is the most preferred host. And people are using tree of heaven to trace it because it likes tree of heaven relatively more than any other host plants. But it can go to hydrangea, maple, oak, pines, sycamore, and willows. In vineyards, grapes, and muscadine, which is very common in the landscape in South Carolina. That's where we are worried that is gonna go in natural habitat and stay there. And hops, it can go broad host range. You will be surprised some hosts which are not listed, but it will go on them. I just want to quickly show you how to identify a tree of heaven. It's not common towards the northern state, but it's always good to know about it. So there are obviously the bark is very gray bark, and it's very different from normal bark. But the thing which I've been using is they have this leaf has with granular teeth, which I'm going to show you here. If you see, this is the tree of heaven branch, and if you see this tree at the leaflet, or leaf you will call this, has a granular teeth both side. That helps. And but it's not very common towards the northern side, northern states, but it is something which is considered a reservoir for this species. Okay, so we developed a diagnostic field guide which is available online, and we aligned these life stages with the calendar. If you Google it, you will find this in the top searches. And there's a QR code here too if you want to use it, but it is available online. Another thing which I want to introduce here is the checklist which we prepared for next 1 year. In this checklist, we have provided images, calendar, and also provided what what things you have to worry or what actions you can do according to season. And this checklist is made for nurseries because it's gonna be a problem in nurseries, and nurseries don't want to be responsible for its dispersal in southern states, especially if they want to keep the trust with their customers. So we have provided each steps in each season in this checklist, which is again available online. If you just search it, you will find it, and QR code is there too. So, beside knowing the diagnostics about its life stages, knowing about what traps you can use, another thing which was very successful in northern state was the culture control, and they're trying to get rid of tree of heaven. If it is in your landscape, if you want to get rid of it, would be the good option. And if it is at a stage where you can use herbicide, like if it is in a seedling stage or is very small, a small plant, you can use herbicide to kill that. That's the cultural control they were using. And in mechanical control, they've been very effective. Is the one you want to remove the eggs as soon as you see the eggs, you want to remove them, because those one mass of eggs can be a huge cause of heavy population next spring. And then using the sticky band around the tree is also very effective. There are some recent studies they found some of those bands are really helping for in those areas where the population is reaching high level. They can reduce the population by using these traps. And then in the last, I wanna also help you to see the chemical control options which are available here. The one which I have in bold on my slides are those which have been proven effective. Again, this will depend what life stage you have. If there are adults and you want to be careful, because these insecticides are very effective. I'm talking about contact insecticide pyrethroids against immatures. So there are carbamates option, organophosphate option, pyrethroids, bifenthrin is something which have been used. And again, it will depend on which life stages you have, what is the population level you have. People are using oil, and when the population is not too high and it is in a residential landscape, they are also using a soap to reduce the population. There is a systemic insecticide option, danotefrin and imidacloprid, which have been in insecticide study from northern states shows effective. There are biological control options. In biological control option, there are parasitoids which can parasitoid eggs, and there are parasitoids which can parasitoid nymph. And then there is the fungicide, there's a fungal pathogen which is Beauveria, which is really found effective at some extent. But the parasitoid, which is the most effective and has been keeping its population under check in the native range, is not here in the US. And we're hoping it will show up itself, because in some cases of invasive species, we have seen that with the passage of time, invasive biological control agents, it just shows up itself. But we know there are studies going on in native range about regulatory process, and once it is done, it is approved, regulatory process are approved, there is possibility to bring the biological control agents from native range. So in the end, I would like to help you to take benefit of this field guide, which we recently prepared. Again, it's online. If you write spotted lanternfly and Google this field guide, you will get this most of information which I provided in this talk available in this field guide. A QR code is also available on this slide if you want to use it. Okay, that's all from my side.
Thank you so much, Zee. Really appreciate you went over this invasive species, especially spotted lanternfly that's we are hovering around right now. If you have any questions, this is the time about anything that talks about the IPM the process of diagnosis to all the way to management, the steps that he was talking about, or about spot on lanternfly, this is the time to ask this question. So since we are waiting for the questions, let me ask you this question. How many counties you are finding this this pest now in South Carolina?
I don't have updated map right now with me. When I saw last time, it was at least 5.
Okay, in 5 counties you
Yeah.
are finding? Okay.
Yeah. Initially, it was 3 for sure, and 2 were added afterwards. So I'm not sure if it'll be more at this stage.
Have you confirmed that we have established a population in those areas?
I think informations are with the regulatory agency, and we are planning to visit, and they are far from our side, from me
Okay.
where I am. But yes, based on my information, they are. Yeah.
Yeah, I'm still waiting for some questions. Looks like your talk was very clear, and it was really clear, very explicit, and very detailed. All that we need to know about their, about this pest. If you have any lingering questions, this is the time. I'll just wait for like a couple more, maybe a few more seconds, and if not there, I will wind it down. Okay.
I guess it's the end of the day, so
Yeah, that's right.
yeah.
It's part of it. Yeah. Okay. Thank you so much, Z, for your excellent presentation. Okay. And I really appreciate that.
Thank you for inviting us.
Yeah. To get the time to come and talk to us. And thank you.
Sure.
Okay. Really appreciate it.
Bye.